In this video, we'll determine the exact values of some trig functions using degrees. So our first one is, let's find the exact value of sine of 330. I drew the x and y axis. It's just going to be a sketch here. First thing I want to do is sketch. I put my arrows, I put my x and y, and I draw this rotation. 330 degrees. Well, starts at an initial arm. Make sure that initial arm is clearly visible. The initial part of the rotation. And rotate 90, 180, 270. So that's somewhere in quadrant 4. Let's put a terminal arm there and label the rotation. This is a 330 degree rotation. And then there's some related acute angle here, which I'll call B. Sometimes I call it beta. So, step 1, sketch, done. Step 2, calculate the related acute angle. Well, beta, or B, if you don't like Greek letters, is just going to be a total of 360 degrees, because it's 360 around a whole circle. Take away this 330 rotation. In other words, the leftover angle inside here is the full 360 rotation minus the 330 we have. So obviously beta is 30 degrees. Step 1, sketch. Step 2, related acute angle. Step 3, write down what we're solving. Sine 330. And notice that it's going to have to be equal, this rotation will have to equal sine of 30 degrees. That's going to give you the same value. We're going to find the exact value, but these two values are equal, so we're almost there. I left a little space though on purpose, because when you're in this quadrant using the cast rule, you can write it down if you want, only cosine is positive in this quadrant, so that means that this is actually going to be negative. Okay, now we got to draw a special triangle which has a 90 degree here, and this side is 1, which means this is 30 degrees, and this side, something you just have to know is that how to draw that special triangle. The big angle is across from the big side, little angle across from the little side, and this is a 2. So the sine of 30 degrees is 30 degrees is opposite over hypotenuse, and you get negative 1/2. So I've solved this one. The sine of 330 equals negative 1/2. Done. You could check it on your calculator if you want to. What's the sine of 330? You get negative 0.5. But we've solved it without our calculator, which is good. It worked out to a nice even number. But if it had been a fraction or a root, like a radical like this one, would have been nice to use this method because it gives us an exact answer as a fraction, no decimals, which is what this question's asking. Let's look at question 2. It says, solve for theta this time if cos theta is negative root 3 over 2. Same thing. There's always 3 steps. Sketch, related acute angle, and solve, or sketch, raw, solve. And we're going to do the first step again, sketch, drawing our x and y axis. But in this case, let's assume, it wasn't written in the question here, but let's assume, I'll write here, given that 0 is less than theta, maybe less than or equal to, which is less than or equal to 360. Because there's going to be an infinite amount of places where cos theta equals negative root 3 over 2, but only several between 0 and 360. In fact, knowing your rotations with this cast rule I just mentioned, there's going to be exactly 2 places where cos is negative. The first place is going to be here in quadrant 4. Oh, no, quadrant 4 cosine is positive. So let's write that cast rule to make sure. And before I forget, let's put the initial arm. There's my initial arm. Okay, where's cosine negative? Cosine's negative right here in quadrant 2. It's only positive here and here. Everyone's positive in quadrant 1, and everyone's positive in quadrant 4. Okay, so cosine is negative in both those spots. Alright, well, draw my rotation of this, and draw my rotation of this one, and label them. I'll call this theta 1, I'll call this theta 2. There we have it. So now I've got my sketch done. Now I want to find my related acute angle again. Always 3 steps. Sketch, related acute angle, solve. So my related acute angle, I'm going to label them beta or B. They're the angle of each arm with the x-axis. So it's the angle right here and the angle right here, they're the same. But when you do related acute angle, you're like inside a triangle here, and they have to be positive. So rewrite the equation, but solving for beta inside these triangles. So we're solving the positive version, the acute or related acute angle of this same equation with the beta. How do you solve cos beta equals root 3 over 2? You solve it by inversing cosine. That is, taking the inverse function of cosine on that root 3 over 2. So let's use our calculator. What's the inverse cos or shift cosine? It gives you cos to the power of -1 root 3 divided by 2, and I get 30 degrees. So my angle inside this triangle is 30 degrees. Sketch is done. Related acute angle done. Let's solve. Theta 1 is in quadrant 2. In quadrant 2 it's always the same formula. It's 180 minus this related acute angle. So 180 minus 30. So your first rotation is 150 degrees. Done. But we have another rotation that's possible that would have given negative root 3 over 2. That's theta 2. And theta 2 is in quadrant 3, which is always 180 degrees, half a circle, plus this related acute angle beta. Go 180 plus beta, which is 180 plus 30 in our case, or 210 degrees. And we've solved it. What we did was determine exact values of trig functions. Here we did sketch raw solve. In question 2 we also did sketch raw solve. And look, you can even check your answer. What's root 3? Oh, negative root 3 divided by 2? You get negative 0.866. Well look, what happens when you do cos 150? Cos 150. Same thing, negative 0.866. What happens when you do cos of 210? Negative 0.866. So we've got it. We solved the exact values of trig functions.